I'm going to try my best to give you, in a short amount of time, a backstory of what we often talk with our users about. I mean, you're a very special group. I mean, CIOs are really special. You have to both, chop wood, haul water, keep the lights on, and also your bosses expect you to innovate. Our poor CIO here, the poor guy, God damn, is he here? I want to make some jokes about him as we go through. But anyway, he's always under the gun by 12 directors that run our organization, and most of them, of course, are quite technically literate. So they all understand the future and their own little spins from marketing and so on. And then he's got to, pay the bills and keep us all getting paychecks and so on like that. So for some special moment, I want to simply say I really appreciate your work, and particularly in the public sector. It's not an easy job. I'm going to cover transforming organizations using what I now call geospatial infrastructure, and I'll try to define that. I have in mind that I'd like to first, of course, welcome you, but then go through some examples of what people are doing, your peers and your users in various places. Then get into the vision for what's going to happen next with respect to geospatial. This is probably intriguing to all of you. And then I'll go deeper into functionality, work that's being developed here, architectures, and then strategies. Make sense? Anything else you want me to cover? All right, I'm going to go pretty quickly. So, purpose of this meeting, I think Christian did a nice job. It is definitely to look at business value of GIS, understand the technology, understand applications. But at the same time, it's also for you to learn to connect with other people, build a kind of community, share, and grow. And hopefully out of that, helping you be more successful professionals. And again, Christian did a very nice job of characterizing who you are. And one of my big thoughts is that I'd like you to become a kind of community. And we always start this conference off by having you all stand up and meeting some new person. Can you do that for me now, please? Just tell them who you are, where you're from, etc. Look, that's good. Thank you. Sit down. Look, that's exactly what we need to do this week, is get to know each other. And by now you are starting to realize there's much richer stuff in this room than just what you're going to hear from the stage. It's amazing, because I always believe in sharing experienced experiences, not non-experienced experiences, or sort of BS, or not false news, but I don't know where to go on that. It's just, and only you guys can really speak about it. I'll try to share my experiences here and have you get to know me a little bit better. This organization is now 50 years old. We started it with the idea of driving rational thinking and systems analysis in the environment. And then it moved to city planning, and then it moved to cities, and then it moved to utilities, and then it moved to a whole bunch of different things. We now are $1 billion company in this country, and then about half that overseas. We're growing, double-digit growth now, and it keeps accelerating for some reason. I think it isn't Christian. Must be, maybe it's Christian, I'm not sure. But I think what I want you to know about us, just like you're trying to get to know each other, is that we are financially very strong. We're a private software company. I think it's the 4th largest in the world. And we care about our users. Our whole focus is on how can we help you do your work better. Build technology that helps our users do their work better. That's kind of the way we're wired. And then at the same time, look at some other things like raising the bar of geospatial literacy, or in education or in conservation. This is how we're wired. We don't have stockholders, so we don't have quarterly craziness going on. And so we make it up based on what our users tell us. That's why this meeting is very important to us, particularly you, this audience, to give us feedback and direction about what we're doing right or not doing right. But you can sort of guess that we are very wired to try to be in service to you. That's as simple as I can make it. And you, in turn, in public service particularly, are doing the same thing in your organizations and ultimately to your citizens. Our users are mostly public sector, about over 50%, but then a lot in universities. We are very active in business and growing leaps and bounds in that space. It's sort of like business woke up to the fact geography matters or something like that. I can't really say it. The big things that we believe in, or I'll just assert to you, is that GIS and mapping and this thing I'll characterize as geospatial infrastructure have fundamentally never been so important. And the evidence of this is in applications that we are seeing. We have about 350,000 organizations. Each of you are one of those that we support, and they produce these amazing results. They are working on the environment and environmental conservation, from little water samples in a stream to climate change and biodiversity for the planet. They're working in natural resources, like on the lower left here, drilling for oil using AI and GIS, to the idea of managing timber, or virtually every big oil company uses it, every mining company uses it. Agricultural organizations, from precision farming to looking at best places to invest in certain kinds of agricultural types. In the world of land information, this means like your little parcel. It's not just the boundary mapping, but also all the attributes with it for valuation, something that everybody is really conscious of in government, taxation, the foundation for the civil society. We're big in that. We have thousands of users, not just in the US, but all over the world, that are building that social infrastructure. And in looking to the future, our users are doing design work and planning work, urban planning, as Christian mentioned, looking at rejuvenating cities, looking at building whole new cities, and communicating with their public about it. Definitely our users help make a place a safer place, cities, crime patterns, predicting crime, looking at security for big events like the Super Bowl, etc. And looking at access to things like fire hydrants, where do we have coverage? And in this lower left-hand corner there in Philadelphia, anybody from Philadelphia here? Okay, you rock. Philadelphia is a long user, and what they're now doing is combining all their geography data to really figure out where they should invest in public safety investments. These are examples of moving GIS into buildings. So big hospitals, university campuses, combinations of public and private sector organizations are making rooms come alive. And this is important in the E911 world where we have to navigate into buildings. These are examples in transportation. Again, road safety, road status. This one in the upper right I like. It's as the sea level goes up and the ice comes back, whole new corridors for shipping across the north. Our Canada colleagues up in the north are opening up, picking the right places for bicycle sharing sites, preparing for disasters. I was with the governor of Missouri yesterday, and they have all these floods that keep happening there. He's just, how can we make the state of Missouri more resilient? This is fanatical, because it's billions and billions of dollars of investment. So in the public sector, it's not just protecting public from fires and earthquakes and so on, but also responding correctly. And in the broader horizon, you can see in Massachusetts, they're looking at sea level rise and how they build resilient communities. In the social sciences, as we would call them, demographics and statistics and health information are showing us where to locate facilities. They're giving us a sense of what's going on dreadful things like opioids, and giving us dashboards for healthcare provisioning around the world. there's a new kind of maps that are being made, and there's roughly 1 billion or so of these made every week. And this is just beginning. It's like a new language. I'm on the board of National Geographic, and by the way, they'll be here this afternoon if you want to meet some interesting people. People are starting to publish their story using a web map. And all of you guys have stories, all of our users have stories, but publishing the stories with text and photos and then communicating is a new language. And this digital kind of communication is just taking off. Portals, I'll come back to a lot this morning, are a new way of organizing geospatial infrastructure. They connect all the distributed services and then, in some cases, make them available for citizen access. Adopt a storm drain, adopt a tree, this started in, I think it started in Philadelphia, didn't it? Like adopt a fire hydrant or something like that. And also citizen reporting, and just the whole world of open data that you guys are challenged with, and this all can be brought and is increasingly being brought alive through geospatial systems. Look, all of those are stories, all of those are little examples that give you some evidence that this is important. So my big assertion is that GIS is growing up from a mission technology to an enterprise technology. And some of you are actually building these with the new generation of web services, and we'll look at some of those in a moment. And in all cases, I guess you, as business people, I mean, you are, from my perspective, you are the business people of government. You're the watchdogs. And what I'm always excited about is talking with you, because I feel like if I can convince you of the productivity value or the improved decision making or the way to transform and make governments more transparent. I mean, if I can convince you, I can convince anybody, because you are the ones, really, from my perspective. And so I want to just acknowledge you and thank you for being here. The vision that I have is that geospatial will be more than simply making maps, that it'll rise up to be a kind of infrastructure, a kind of nervous system. That's my analogy this week anyway. A kind of nervous system for organizations. A broad network for the planet is emerged called the internet. And what we're connecting to the internet is measurement systems, IoT. We're connecting satellite imagery to the internet and immediately making it available. And you'll see the enabling tools to do this. So we can hypothesize that at this particular moment, what's emerging is a nervous system for the planet. And I've been studying a lot about this because the theme of this year's users conference is going to be the nervous system. And part of the nervous system is your brain, with memory and analytics, of course. So the analogy I have is kind of fun to play with, that we are wiring up the planet for good or bad, good and bad, I suppose. And GIS is playing a central role in that. Well, down back to earth here in your organizations, my assertion is that you're also wiring up your organizations with a kind of nervous system. It's a different kind of IT. It's pervasive, it connects everything, it's integrative, it's inclusive, it's, all those I words. It's kind of interesting. The backbone for that is that this emerging infrastructure is built on a science, and the science is geography. So as we think about our own personal lives or our own families or our own organizations or our own cities or our own societies or our own countries or even the world, framing it with geographic science as a foundation for the technology is really kind of fun. The world that we're living in is all interrelated, and we read about it in the paper. This goes off and that goes off, and somebody has this policy and everything changes. The science of geography frames the world into two categories: the human world And we have all the sociology, technology stuff that's associated with that. And then the natural world, the stuff that National Geographic writes about. And as we frame these down, we can begin to see the changes and also the interrelationships between them. So it's a really fine science to understand our world. And today, part of the reason I suppose all of us are a little worried is that there's lots of challenges that are emerging, and we can see the evidence of these challenges like climate change or overpopulation or migration or immigration or pollution or even the whole polarization of our country today and the world in the frame of geography. We can see it. We can actually see things that are really amazing. Well, not everybody can see them, but people that work with GIS can actually see them. And from my perspective today, we do need more understanding. I mean, you need understanding in your own little shell, your own organization. You know, where are my people? What's going on? Where are we spending money? Where's their taxes? What are the issues? Where's the crime? All of it. We need more understanding of it. And also we need more collaboration. And then ultimately we need action by people. So the question always is, what should I do given this daunting future that we're all facing? And there's lots of things going on. I don't want you to believe that GIS is the answer for everything, but what I believe our community is doing is they're applying the power of digital geography to all sorts of things. They're transforming organizations ultimately by bringing things together, building smarter cities, conserving nature, figuring out where we're doing bad footprints and good footprints, directing, making things more efficient. This is one of the big things we must do. Conserve nature, make things more efficient, make places more urban. And for you here, the message, I think, is we have to keep learning and integrating and evolving. This paradox that you're facing of, on the one hand, keep the lights on the other hand, why can't you transform our organization digitally? You know what I'm talking about? How do you do that? How do you do that? It's difficult. Well, my thought is if we're going to address the big challenges in your organizations, but planetarily as well, we need to use our very best technology. And we have to keep learning it. I'm challenged with this all the time. I keep trying to figure it out and study it and get involved. We need to also integrate our best science into it. And from my perspective, it's geography, the sort of mother of all sciences. You can quote me on that if you want. And then holistic design thinking, bringing all the parts of an organization together so we can think. And mayors want this, governors want this, your bosses want it, the policy people want it. They want to bring it together so just like your mind does, so I always think, if only I was boss, I could really address the problem, all of this complexity. Well, it's hard to do. So what we're toying with is a framework as we get this meeting started. We like it here to call it the science of where, which is bringing all the measurements in, seeing them with visualization, then analyzing them, like overlaying maps and seeing relationships, and creating understanding. And then supporting decision-making and planning and designing so that people can actually build a strategy and take action. So this 6-step method, we just sort of made it up over the years, turns out to be the real reason why people buy GIS. It isn't the visualization, or it isn't the storing of system of record. No, it's a process and a framework which can underpin virtually everything. And it doesn't have to be everything. It can be totally invisible in the background. But the method, the framework, the process of connecting the dots. I mean, you take in a city, there's surveyors. Man, they are red hot about surveying. For what reason? So that people can see and analyze and run the city. Or you take foresters, same thing. There's inventory guys that go out and they inventory, or water people, same thing. Or NOAA, they spend gazillions of our taxpayers' money measuring the atmosphere, but it isn't until it gets visualized and modeled and tells us what's happening with the weather that it really becomes valuable. So what I'm saying is that geospatial infrastructure is a framework that ties all these various pieces not only within your organization, but also between and among organizations. The city and the county responding to a disaster, the state and FEMA responding to hurricanes. You get this idea? So, I can talk all day about this picture. I'm very fond of it because I think it's really important, and I'll return to it. I think that picture actually shows that GIS will be an instrument of evolution. So as the nervous system kicks into place, this ability to dynamically in real-time measure and dynamically in real-time respond, just like your body does to heat or some stimulus, this is an instrument or a framework that will actually help us not only in our organizations evolve, but also ultimately the planet evolve. What is this infrastructure word? From me, it's GIS at scale, and it has three important parts. One is the content part, being able to create geospatially available data. Second is analytics and visualization or mapping. And the third is the power of integration that location has. I can take this data and this data, overlay it based on location, and I can do more than if I was in my own stovepipe. And this platform is for sharing and collaboration, what everybody needs and wants. And it creates understanding and allows us through this visual medium to solve problems. And whether it's Starbucks locating a store or a fire department needing to know where the next fire station is or respond to an event, it's all the same language. And this is very rapidly advancing. New advances in remote sensing and IoT, new advances in distributed computing and AI in computing, and then I hope to give you a little flavor of the kind of things that are happening within GIS innovation in analytics and visualization. Now, these forces over the years we've been tracking. We have 1,200 people in our products unit. All they do is they look at these trends as well as what our users say, and they say, okay, here's the next thing. And that's very hard to do. The next thing, some of you know this, the next thing is a new pattern. It's not so new now, but it's a pattern of web GIS that is much easier, much more accessible, much more open. You think that's me? No, I guess not. Anyway, I'll try it. Is it you, Kristen? You don't think so? Okay. So you get this pattern. What is the pattern? The pattern is a kind of platform, but it's not, a mainframe platform. It's not an Oracle database platform. It's a distributed GIS, which is interconnected with services, which can dynamically bring data together in a kind of a virtual environment, a shared virtual environment that supports an individual or teams or whole organizations. And as you'll see at the end of this talk, even whole communities, meaning the whole community of Southern California or the whole community of emergency responders. Now this for UIT folks can be thought of a little differently. GIS's history has been that it's primarily been in the mission, as you would call it, in the business side. And it's been great with client-server technology or desktop technologies, and it's been great. But what's emerging is that WebGIS not only supports that, it is me. It not only supports that, but it's also becoming a services platform. In other words, make the data spatially related. You see how this is? Like you take an address file, you can geo-address it, you put it on a map, it suddenly spatially enables the data architecture. And most data actually turns out to be spatial, but it's never been explicitly defined that way. So you see how this works? So it lives inside of the classic enterprise architecture, but it's also outside. Kind of clever in that sense. So this WebGIS architecture supports lots of ways to implement it. You can just be the lonely GIS person doing projects, project by project, now being served out of cloud services. Or you can build an enterprise kind of system, a departmental system with multiple users being served by services. See, the big deal is services. It's not traditional client service, like dial tone geo. That's the way I think of it. And then what's emerging and where it's really exciting to me about this geospatial infrastructure is that it's now evolving to where you can have multiple distributed systems, either in category 1 or 2, that can interconnect through a WebGIS portal. It's not the portal is the wrong name, but we're calling it portal. That can register and you can discover distributed services, and then that software actually allows you to integrate dynamically the data, overlay the data, mash it up, and create new data products, as if it's in a single store. You with me on this? Okay, if you're not, leave the room. So what makes this architecture interesting is a whole bunch of little things. It isn't one thing. Web maps, web apps, distributed content, dynamically fusing it together, location analytics, visualization. There's a whole bunch of little things that integrate together, but also are powered by strong, fueled by strong databases and strong analytic tools. So let's look at some of them. One of them is something called a web map. A web map is like a Google map conceptually in your head, but it's not. A web map is a technical specification. It's basically a REST service and visualization thing with an open API to it that allows you to create a web map in one location and email it to somebody else. And that web map can be the combination of other data sets in a distributed frame. So in some of our more advanced users, as you'll see in a moment, the web map is becoming like a language. And this web map is created from lots of different data sources. So this portal technology allows you to bring any format, I wouldn't say any, but most formats together and express them in an abstract way as a web map. So you take imagery, and it's a big image store. I flew the city, and you can view it as if it's a little like a Google map. You can interact with it, you can query it. Same thing with traditional tabular data with an address link in it. Or you can bring in a BIM map and see it as a web map, except that it's a 3D web map. We call it a web scene. So by normalizing all the data this way from any source, you can leave the data where it's at, and you're viewing it, the view frame, is a map, or you might call it a report. So you know the concept of SharePoint? Any of you guys know what this is? So you have SharePoint views. SharePoint view might be from multiple tabular databases. We basically ripped off that same idea, but took it much further by having the ability to abstract any kind of quite technical data into this view. And just like you can do dynamic joins in SharePoint and then persist them, you can do the same thing here. And by doing all that hard work, a simple set of tools, abstractions, can be accessed by almost any type of device. You can see it in a browser, you can see it on a cell phone or on a web. You can see it on a desktop. You can see it in a dashboard. And the magic is as these databases change, for example, real-time thumping away IoT, the view changes dynamically. And by making that abstraction separation, it just opens the door for lots and lots of creative work. And the apps that are the receptacles of this, it's basically maps and apps, that's the language, maps and apps. The apps are taking this science into the boardrooms, into the daily briefs, into citizens, into engineers, and you add to that story maps, which are built on web maps, and boy, it's like this explosive language. It's just starting to take off. And some of those apps become very intriguing. This one is called Insights. It's just very similar to Tableau, except it's like a spatial Tableau. You can drag and drop and do spatial BI and explore, spatial links and analytics. It means opening up all the hard stuff to normal people to do data exploration. At the other end of the scale in analytics, about 2 weeks ago, we just integrated in Python notebooks that are persisted. So you can have Pythonic notebook expressions which can integrate big data, data lakes, open data science tools, machine learning tools, and bring them to life with a geospatial frame. That's very attractive to a lot of the data science organizations and probably working with you and for you. So this portal I've been talking about quite a bit is a piece of software. Of course, it has a catalog where you search it and you can find things, but much more important is that it organizes all types of geospatial information. It organizes those dial tone data sets that I was mentioning. It also organizes models and notebooks so you can search and discover them. Also, when people mash data up and do projects, it organizes and persists with metadata the result of the project, so other people can search and find your work. So right away you start to see that it's a sharing system, and then it manages identity and manages groups, all in a nice little store, a nice, interesting, easy way to use the data. And this portal is starting to create some noise, and especially in large federal agencies, where they're having all this distributed data sets, and they can bring them together using location as a common key. I would simply assert it's driving transformation, meaning that different operations in a distributed environment are suddenly able to be discovered and fused dynamically and create apps on top of it. Man, that's like a golden ring in the history of government, because that's what everybody wants. They want integration, and they want real time, and they want AI behind it, and they want it simultaneous, and they want to collaborate. So I'll just say this is for me the big deal about geospatial infrastructure, is it's going to bring not just GIS together, it's going to bring all IT and mission critical systems together. So you might say, that's just Jack talking. No, I'll give you some examples in a city. WebGIS is a foundation for smart cities. You can take distributed data sets in different departments of the city, take LA, take Abu Dhabi, take New York, and organize them in a portal and then provide access to the public through them, or have dashboards that give real-time information about them. Abu Dhabi is one of our largest users. They have this thing that they're building this quarter called a MIC, and it wires together real-time information about everything so that their rulers, the so-called executive council, can come and talk about issues geographically from different departments. In New York City, they're wiring up New York with real-time data feeds, cameras, traffic, Waze kind of stuff, sensors, and making it available so people can query it. Not for everybody, but particularly for some people. In Los Angeles, it's still just getting going, but the hub work there, their Geo Hub, is opening up their fused portal information and making it available for citizens and neighborhood groups to work on issues kind of like they do physically, but this is virtually. And that's changing things. Okay, I'm going to pause for a second there. Was this interesting to you so far? So I basically covered some of what our users are doing. I covered some of the visioning of that there's a new, there's a new thing in town. It's the WebGIS architecture, and that I'm seeing that live bring, for example, in the United States, all the national security agencies, CIA, DIA, NSA, the NRO, all of them are coming together using a hub, portal hub. And that's changing behavior of American national security, by the way. And I'm also seeing it in cities. I'm seeing it in counties. I'm seeing it in businesses like Shell Oil, distributed system all around the world now, being able to access it, fuse it, see what no one else can see. So powerful. I'll now jump into, and Christian asked if I would move more quickly here into the technology that supports this in the little nice film, Christian. We talked about the Esri geospatial cloud. It's not really a cloud. It uses other people's clouds, in fact, but it's a virtual cloud. It's a hybrid cloud. It integrates virtually everything that we're doing, ArcGIS Online, which has about 8 million users now, with all of our enterprise technology. So our main direction is to create useful technology and support our users in doing their work better. I said that before. And we do it with ArcGIS, our software and cloud services. And we're entering into a new age this year by also supporting these things called geo-enabled systems. And they're not the same. People are very successful building solutions on top of ArcGIS, and there's millions of them. But we're taking some of that code and building systems which don't require you to be a GIS person. They just work and they're responsive to specific workflows. And I'll share some of that. Anybody interested in that? Because I could leave that off if you're not interested. 2 people. Okay, that's it. I worked all night for that. I really love you, man. It's good. This Esri geospatial cloud is a new framing of what we've been doing for many years, services-based architecture. So we have ArcGIS, and it supports 3 communities. One community is the traditional GIS community, systems of record and so on. Another community is developers, and in January we opened up the hood of all of our lower level tools with open APIs and made a new developer program, which is free for developers to develop high-end solutions, embedding some of our content. And third is supporting the mapping and location world. And the market tends to segment these into 3 categories. We think of it as just ArcGIS that has 3 faces. And it's licensed in different ways. It's used by different people. And then there's the geo-enabled systems. So you know that Microsoft has Azure. How many of you are Azure customers? Quite a few. And you can buy Azure as SaaS, like SQL Azure, I think it's called, or 360, Office 360. Or you can buy Azure on-prem. Same here. So we say we have about 8 million users, and some of them are using our online services. It's not completely everything that on-prem does, but it will be. Or you can buy ArcGIS completely for on-prem work. And we are not moving from one to the other, like Apple or, like Autodesk and Adobe did. We're not saying suddenly everything's going to be cloud. We're saying we support cloud services and we keep getting them better with partners. And we also deliver software, and our commitment to our users is, and we have to, given the sensitive nature of a lot of our users, we have to have both of these approaches. So ArcGIS, I'll start with that, is a comprehensive platform. It has servers, desktops, apps of different types, and it's completely open. This system is, we often say, 3 systems in one. And this is unusual in the IT business. It's a system of record like land records, water records. It's transactionally updated, so on. It's also a system of analytics like the BI platforms would be, so spatial BI. And then finally, it's a system of engagement because maps and web maps and story maps, they just engage people. they really do. And the Hub initiative I'll talk about later. Anyway, all three of these are one platform. And we engineer it so that you can do all of this interesting integration about location with one platform. And we got lots of stuff going on here. We spend about 31% of our revenue goes into R&D. So there's those 1,200 engineers over there in that building. Sometimes you'll probably take a tour over there, hopefully. And they're just kicking it with respect to different innovative work. One of those categories is building online content. It's kind of like a Google map or a Bing map or something like that, but different in the sense that there's thousands of them. So you can, if you need soil maps, you need land cover maps, you need imagery from yesterday, you can just dial into it. Your ArcGIS subscription or license allows you to have access to those thousands of layers. So we spend millions of dollars every year curating government data, patching it together, and serving it back to our users for free or as part of our platform. And then in this same exact platform, we have over 20 million data sets and maps that have been shared by our users. So users are using each other's data dynamically. We call this the Living Atlas, and it really is worth looking at rather than your own imagery or your own base maps. On the other hand, some of our users give us their base maps and we host it for them and serve it back to them for free. So it's really a neat thing. It's not Facebook, but it's growing, I guess that takes on special meaning in this audience. We make on that platform about 1 billion maps a day, pretty much, every day. In the mapping world, our innovation is in smart mapping, it's in production mapping, and it's in mapping like maps for Power BI, maps for Office, maps for everybody. So we have these three buckets that we organize our work. While this is not a map, it's sort of a map. We have a tool, an app called Dashboards, and one city, I think it's Wichita, is that it? They have like 300 dashboards. They're looking at everything that's going on in the city in real time. It's really a very performance dashboards, where everybody is, etc. Lots of work going on in 3D mapping and visualization, and the frontiers of AR and VR you'll be able to see out in the lobby. And field apps. This one I especially want you to pay attention to. We started in this activity with something called Collector, something that would collect data in the field. And then we connected it to the system. So as you're connecting in the field, your data is going into a server that everybody else can see, or whoever you want to have see it. We've added to it statistical data collection, the Survey 123. This is now the backbone for the census in a number of countries, and our own U.S. Census Bureau is using it. We just added something called Tracker. This allows your organization to track where the employees are at any one time. And people always make jokes of a slacker tracker or something like that. That's not it. It's safety. Well, it is. In your case, Christian, sorry. I'm always trying to figure out where you're at. But anyway, more importantly, security. So when a hurricane is coming, I want to know where my people are, and I want to get them out, or I want to know it. And all that's connected so that I can also see, collect data, navigate. This is a big deal. Real-time wiring up of cities and natural areas is happening, and we have a real-time analytic engine that allows real-time IoT-like information to come through, whether it's stationary or moving, and be seen. There's thousands of organizations that have now deployed this. So what is a smart city, for example? It's wiring up all that's going on and then seeing it in real time and deploying and responding as a result. And in imagery, our tools have been extended to do all kinds of image analytics. So rather than buy a separate image processing or image data management system, your GIS actually just does it. And analytics, people have been talking about recently, data science and analytics. Spatial analytics have been really around for 4 decades, and they're fantastic tools to create understanding, particularly in the space-time world with big data. Network analysis, raster analysis. You guys interested in this at all? Yeah, it's really the meat of what many people think of as a GIS. And our work here, as I mentioned a couple minutes ago, is advancing with the introduction of Python notebooks. These are hosted notebooks that are actually part of our code now. And what that means is the notebook server can actually do interactive programming, which wires together functionality in the whole open science world, also big data stores, data lakes, and also our own geoprocessing tools. And I can just program interactively, create a beautiful model, and then persist it and share it with other people in the organization. So we think this is a big advance. It's a way to not only do great science, but it's also in a practical way to just automate things, script things. So a lot of people are excited about the AI stuff, but really just doing the normal scripting makes people pretty happy. And speaking about AI and machine learning, that Python environment allows us to take GIS, which has lots of machine learning tools in it already, and connect to the big cloud environments for AI work, both the platforms as well as the frameworks like TensorFlow, to scale it up with 10 billion images to do feature extraction and identification of interesting things that is important for government. The last thing I think I'll say on this platform is that it's open, and we spend a lot of time on this. We support all the open standards, OGC standards, ISO standards. It's really important. It's also, there's a large piece of it that's open sourced. We're the largest geospatial company in GitHub, for example. We support now the integration of open science. We support open data. We have open APIs for developers, and we foster a community of users. So everybody has their own definition of what is open. These are our 6 definitions. And the evidence that this tends to work is shown by the tens of thousands of successful systems which are operating in heterogeneous environments. Okay, last technical part I want to talk about is the products themselves. Again, I can skip this if you're not. Tell me if you're interested in a deeper dive on this. Okay. So, as I broadly painted before, there's 2 categories. The ArcGIS products, and there's these emerging geo-enabled products that people can just start using. You don't need GIS backgrounds. And they include the online technology. This is this massive library of living atlas information, but also hundreds and hundreds of functions. So for a few $100s a year, I can subscribe to this as an outside organization and just start doing GIS in a simple to use environment. And we keep improving that. But actually, it's also an integral part when you license our desktop. You pay $1,200 for the desktop. You get this, $500 million of content and rich functionality and shareability and publishing environment in the background. It's kind of like if you buy iPhone, you can get iMusic. Well, I guess you don't actually. You have to pay for it. You don't here in this case. That was a snarky remark. Sorry. I'm trying to get you guys thinking that this is an integrated system. So when you buy into it, you get the other parts that come with it. That's the idea. The corollary to ArcGIS Online is the ArcGIS Enterprise, and this is the on-prem system. This is a heavy lifting system, and here, as I mentioned, we just integrated in Python notebooks. There's, from our estimation, about 300,000 of these enterprise servers that have been set up and then connected with ArcGIS Online bringing in complementary data. And we keep pushing the envelope here. In machine learning, the big thing this year, towards the end of this year, you'll see more work in containerization and microservices. So this keeps evolving to stay current with the latest trends in computing. Late last year, we changed our licensing model to include role-based licensing. So instead of buying a whole bunch of technology and that's how you license it, you can buy it based on roles. And people have been on us for many years to do this. I can either do it by time or I can do it by number of users or both. And I can start with a $100 viewer. I can go up to a $5,000 role of a professional. I can do it for three months or 3 years or like that. So we're changing. We're kind of putting our foot in the water in that environment. Particularly, this is appropriate for SaaS applications, but it's also an alternative new way for licensing on-prem technology. Are you guys liking this? I'm kind of curious. Or you're not sure? I mean, it really makes things much more affordable, much rapider, and more scalable over time. So I keep testing this with users. Some users, they just want their damn code, and that's it. Nothing wrong with that. I mean, you're one of those guys, aren't you, Christian? Really? Yeah, I thought so. Yeah. Well, I'm using humor to try to characterize that we're in a transition, but we're not moving away from something. We're adding something, and that's basically what our users tell us. This enterprise technology is really scalable. It really has the basic enterprise server. It has the portal that comes with that server, providing broad access, and then it has some specialized servers for big data analytics or image analytics, and it can be set up with classic monitors to monitor the performance, etc. And it also operates in a distributed environment. So in a typical city, I might have a dozen servers, and the portal allows me to do a system of systems. So I can have my public works department, my fire department, my police department, they have their little systems, but the abstract data that's held in the portal can be replicated dynamically. And that replicated data can also go outside the firewall into community-facing portals for access and lighting up the community. So we spent a lot of time on this. You're an audience who would actually understand the value of it, but when I again talk about infrastructure, think about this for a moment. Infrastructure for a whole agency might have 25 different departments. I really want to have it all as one system, but I don't want to have it all in a central database. Nobody's going to buy into that. Institutionally never work. So this allows people to have their thing, but also replicate the view into their thing. It's really cool, politically and technically. Okay, for developers, as I mentioned, there's developers in our desktop environment. Our pro environment has complete SDK. But the big thing is web developers. And here we have a whole development team that works on JavaScript 4.0, visualization and analytics. And then there's runtime technology that can drop into devices that people want to carry into the field for disconnected work. The JavaScript thing to me is most exciting. Do you guys all know how JavaScript works? It's kind of like you're in a browser and you have a little software library in the browser that accesses services and does client-side, browser-side processing, like very fast, visualization, various kinds of analytics right in the browser. No software, except that there is a little software there, a little JavaScript. Aren't these beautiful? An interesting part about this is it's all free. So you set up a server, and your developers can take this JavaScript stuff with using widgets and so forth, create a little app with an app builder, and bang, you're in business doing client-side operations really fast. So watch this carefully, because we've spent a fortune on it, but You know, we talk about you invest in your system of record and then you make it available to a larger audience. So those services with these little browser apps that integrate other kinds of content in across the organization is the way I see this going. And speaking about apps, there are app builders in our platform. They're, again, free. They have like widgets where you can drag and drop and build a web app. Last year, about 500,000 web apps were built in the open web. We don't know how many behind the firewall, so probably 1 million. And that whole expensive thing of building apps and supporting apps, I mean, our community is now building apps in hours, and just like they have throwaway apps. You have an app for the fire. The fire is done, you throw the app away. It's really a different age than I'm used to. The other kind of app is for native devices. Here it's a runtime, and again, widgets and app builders exist. So the geospatial app construction, that used to cost maybe $50,000 or something. No, not anymore. You can have non-programmer people actually building apps and accessing your geospatial infrastructure. The last thing I'll talk about is geo-enabled systems. This is this new adventure we've been working on for a few years to say people that don't want to be a GIS type of person, they just want to use the power of GIS. And so we have a half a dozen of them in development. A few of them have been released, and they are one for community engagement hub. This allows us to take and support open data and policy initiatives that the mayor might want to have with his community. Lots of interesting things here. Performance measurement can be exposed out to the community through this community portal. Anybody interested in this here? A few? I'll just say we've radically changed the pricing model so that it's very affordable now. So look at it carefully. Yeah, it really is. It is really going to be wonderful. I believe there's only about 20 or 30 communities that are doing this now. I visited one in Holland last week. It was just amazing what they've done with their community. They're just getting a whole community to work for them. This one guy, they brought in the whole community. There were like 70 people in this room. I said, who pays your wage? Well, we were just volunteers. No. The whole city is called Zwala. And man, it is really neat. So that's one. Second one is urban. This is for urban planning, as Christian mentioned. It's about projects where somebody comes in with a building and they can test it in a 3D model, compare it to zoning plans and land use plans, and also various indicators. And the third one is indoors. This is really taking GIS as a regular enterprise system. So many of you have buildings, public buildings, complexes. This is designed to, it's not for one building. It's not like this building, but this campus, we have implemented it, and now I can find my way to anybody's office. Emergency people with E911, they can find their way to the right place. And also from a security perspective, it's fantastic in asset management and space planning, et cetera. So Christian is giving me the high sign. I'm done, right, Christian? Thank you. Organizations your organizations are, and organizations that I interact with around the world are facing a lot of challenges. And from what I can tell, this is going to get a lot worse in terms of, I don't like to believe in a negative future, but I don't like it. A lot of negative stuff going on. And the only way for me to respond is to, what can I do? And I'm sure many of you have that same spirit. So this idea of applying GIS is already making a difference. I showed you some evidence of that. Conserving nature, making places more efficient, et cetera, better communication, better decision making. But integrating the collective work of our GIS users, this means different departments coming together in a kind of shared infrastructure. It really isn't about buying anything new, it's just about interconnecting the good work that's going on with a portal is, I think, going to transform how agencies think, how they collaborate. You know, the city of LA and the county of LA collaborating with shared services. Or here in Southern California, I'm very pleased to announce that the Southern California Association of Governments, and it's some of you are probably from SCAG, yes, I'm SCAG members, just decided after several years of evaluation to pick this platform to bring together 172, is it 172 governments? 191 governments. They'll all be sharing content and services and using each other's content. Shared services is, of course, the big buzzword, but I'm talking about shared geospatial services. So all of Southern California is going to be able to operate independently as little units, but also be part of this organism of creating a better Southern California. And that big new scale of GIS, I think, is going to require more than technology. You know, it'll take us 2 years to really realize the vision of SCAG. It's going to require leadership, and here in Southern California, we were very fortunate to have some people that really saw it and are strategizing. It also requires a culture of a reculturalization of institutions, and that means collaborative institutions. And by the way, this is happening not just in government, it's happening in science. There's this new age of science, you know, let's have a new kind of science, not my little science that I get to, you know, publish or perish kind of thing, but collaborative science where content can be shared and bigger things can be created. And that's going to be essential. And this collaboration doesn't just happen. It happens through nurturing and talking about it. I'm not a Buddhist or anything, but I got this tweet from the Dalai Lama shared to me the other day. He said, what did he say? He said, collaboration requires friendship. Friendship requires trust. Trust requires some kind of level of intimacy or interpersonal, you know, your friends. And if you have that, then people tend to just collaborate a lot better. So I'm a great believer in meetings like this where you get to know real people. And I don't like meetings because they waste a lot of time often, but those kind of meetings are also the opportunity to really build these kind of trusting relationships. So geospatial infrastructure, I think it's in your future. Some of you are actually building it, leveraging what's already been done. I think it's going to make a big difference in the world. So thank you.